Welcome back. This is the last and final video on the topic of alkane, alkene, and alkyne nomenclature series. This will be the only video on this particular folder because we have already done enough work to get you started on alkanes and alkenes, and things are not that much different. Without further delay, let's get started. Now we can see the three tables that you've been seeing in the previous two folders, and the table on the right and the table at the bottom are exactly the same. The only difference is the table on the left side at the top, and if you notice, all of the anes have been replaced by Y and E, and that's all there is to it. All right, let's actually do some practice, and then I'll leave you with a few problems to practice on your own. So, alkyne nomenclature. Now, since we know this compound is an alkyne nomenclature video, there has to be an alkyne. But what if we don't know what it is? Well, we already know how to calculate and determine whether a compound is an alkane, alkene, or alkyne. And we did that by using the general formulae of an alkane. And if you put 7, we get 16. And we have 14 hydrogens in the current compound. Sorry, this should have been, so 12. So that would be 4 in the current compound, which leaves us with 2 dB. What 2 dB really means is you have 2 double bonds, but then you have the default single bond, which is why we know it's a triple bond overall. So let's go ahead and draw some structures. As with always, you draw the straight chain isomer, and that will be 7. So we can put the triple bond here, or we can draw one more. I think that's 6 only. So let's draw one more. We can put it here. And then let's do one more. Maybe we'll do 5 this time. Okay, and then we'll do this over here. And then we'll do over here. Okay. All right, with that said, let's go now fill it up with hydrogens. So CH3, CH2, CH2, CH2. Make sure you keep track of your hydrogen count. And that's for first one, that'll for the second one. Carbon cannot have more than 4 bonds. So if you've already met the 4 bond requirement, then that carbon will have no hydrogens. It's always a good idea to go back and count your carbon and hydrogen count so you know exactly how many do you have, and you don't end up having too many or too little. Both are incorrect. All right, I've driven 3. So let's go ahead and draw the line structure as with always. 1, 2, 3, 4, 5, 6, and 7. And then it's in between the first and the second carbon, and that's our first line structure. So it's between 1 and 2, right? And there's no substituents coming off of it. So it's a simple straight chain. That means it's 1, and there's 7 carbons, so 1 heptine, right? All you have to do is replace the A and E by Y and E. This is, again, not much difference. It's still a straight chain with nothing coming off the substituent. Only difference being it's between second and third. So we always give the lowest of the 2 number preference, so it's 2 heptine. And this, again, which side do we start numbering from? Well, the side that's closest to the end containing the triple bond. So this is the end that's closest to the end of the chain, which contains a triple bond. So we start from here, 1, 2, 3, 4, 5. We have to first draw the first name here because we got substituents. These are methyl groups, because if you have only, if you draw the line structure, 1, 2, 3, 4, and 5, right? 1, 2, 3, 4. Sorry, I drew one more. Shouldn't be there, right? 1, 2, 3, 4, 5. And then the triple bond is here. And then the substituents are in here, right? That's 1 dot, so it's methyl. So it's 3, 4 dimethyl. and it's one pentyne. And that's it. That's how you do alkyne nomenclature. But the fact we have already known how to learn drawing line structures really helps. Now here's what I'm going to do, and here's all I want you to practice. And as part of the My Thoughts template, you will turn that in. So this is the only one I'm going to practice. So you start numbering from this side. So 1, 2, 3, 4, 5, 6, 7, 8. Your longest chain must contain the triple or double bond. It doesn't matter. So it's 8 means octane. So it's octyne. So we know it's between 3 and 4. So we know the last name is 3-octyne. All we now go to do is figure out the substituents as 1, 2, 3 dots hanging off the chain. So it's methyl groups. It's of 2, 5, and 7. So it's 2, 5, 7 trimethyl 3-octyne. And that is it. These are the ones I want you to practice. Draw at least 3 isomers for this. Name each one. Name this one. Name this one. And you will turn that in as part of your exercise. And that wraps up actually the nomenclature series for just alkanes, alkenes, and alkynes. We would actually get into naming compounds that involve functional groups, and that will be the next big thing that we have to tackle before exam 1. And we also have a couple of other minor concepts that are derivative of this particular concept. So stay tuned for further videos.